Question 16. How does Nagios help with distributed monitoring? Answer. With Nagios you can monitor your whole enterprise by using a distributed monitoring scheme in which local slave instances of Nagios perform monitoring tasks and report the results back to a single master. You manage all configurations, notification, and reporting from the master, while the slaves do all the work. This design takes advantage of Nagios' ability to utilize passive checks, i.e. external applications or processes that send results back to Nagios. In a distributed configuration, these external applications are other instances of Nagios. Question 17. What is the difference between active and passive check in Nagios? Answer. The major difference between active and passive checks is that active checks are initiated and performed by Nagios, while passive checks are performed by external applications. Passive checks are useful for monitoring services that are asynchronous in nature and cannot be monitored effectively by polling their status on a regularly scheduled basis, located behind a firewall, and cannot be checked actively from the monitoring host. The main features of active checks are as follows. Active checks are initiated by the Nagios process. Active checks are run on a regularly scheduled basis. Question 18. When does Nagios check for external commands? Answer. Nagios check for external commands under the following conditions: at regular intervals specified by the command _check _interval option in the main configuration file, or immediately after event handlers are executed. This is in addition to the regular cycle of external command checks and is done to provide immediate action if an event handler submits commands to Nagios. Question 19. What do you mean by passive check in Nagios? Answer. Passive checks are initiated and performed by external applications/processes, and the passive check results are submitted to Nagios for processing. Question 20. Explain the need for passive check. Answer. Passive checks are useful for monitoring services that are asynchronous in nature and cannot be monitored effectively by polling their status on a regularly scheduled basis. It can also be used for monitoring services that are located behind a firewall and cannot be checked actively from the monitoring host. Question 21. What is meant by Nagios backend? Unable to find a relevant explanation? Answer. Both configuration and logs can be stored in a backend. Configurations are stored in backend using Nagios QL. Historical data are stored using NDO utils. In addition, you also have NagDB and OPDB. Question 22. What is database? Is used by Nagios to store collected status data. Answer. Nagios Core will use default RRD database format to store status data. Question 23. What are the operating systems we can monitor using Nagios? Answer. Any operating system we can monitor using Nagios OS should support to install Nagios client, either S and NRPE. Question 24. What are the components that make up the NDO utilities? Answer. There are 4 main components that make up the NDO utilities. NDO Mod Event Broker Module. The NDO utilities include a Nagios Event Broker Module, NDO Mod.o, that exports data from the Nagios daemon. Once the module has been loaded by the Nagios daemon, it can access all of the data and logic present in the running Nagios process. The NDO Mod module has been designed to export configuration data as well as information about various runtime events that occur in the monitoring process from the Nagios daemon. The module can send this data to a standard file, a Unix domain socket, or a TCP socket. Log2 NDO utility. The Log2 NDO utility has been designed to allow you to import historical Nagios and NetSaint log files into a database via the NDO2DB daemon described later. The utility works by sending historical log file data to a standard file, a Unix domain socket, or a TCP socket in a format the NDO2DB daemon understands. The NDO2DB daemon can then be used to process that output and store the historical log file information in a database. File2soc utility. The File2soc utility is quite simple. It reads input from a standard file, or stdin, and writes all of that data to either a Unix domain socket or TCP socket. The data that is read is not processed in any way before it is sent to the socket. NDO2DB daemon. The NDO2DB utility is designed to take the data output from the NDO mod and log to NDO components and stores it in a MySQL or PostgreSQL SQL database. When it starts, the NDO2DB daemon creates either a TCP or Unix domain socket and waits for clients to connect. NDO2DB can run either as a standalone multi-process daemon or under inetd if using a TCP socket. Multiple clients can connect to the NDO2DB daemon socket and transmit data simultaneously. A separate NDO2DB process is spawned to handle each new client that connects. Data is read from each client and stored in a user-specified database for later retrieval and processing. Question 25. What is NDO-Utils? Answer. The NDO-Utils add-on is designed to store all configuration and event data from Nagios in a database. Storing information from Nagios in a database will allow for quicker retrieval and processing of that data and will help serve as a foundation for the development of a new PHP-based web interface in Nagios 4.1. MySQL databases are currently supported by the add-on and PostgreSQL SQL support is in development. The NDO-Utils add-on was designed to work for users who have single Nagios installations, multiple standalone or vanilla Nagios installations, multiple Nagios installations in distributed, redundant, and/or failover environments. Each Nagios process, whether it is a standalone monitoring server or part of a distributed, redundant, or failover monitoring setup, is referred to as an instance. In order to maintain the integrity of stored data, each Nagios instance must be labeled with a unique identifier or name. Question 26. What is NRPE? Answer. The Nagios Remote Plugin Executor add-on is designed to allow you to execute Nagios plugins on remote Linux/Unix machines. The main reason for doing this is to allow Nagios to monitor local resources like CPU load, memory usage, etc. on remote machines. Since these public resources are not usually exposed to external machines, an agent like NRPE must be installed on the remote Linux/Unix machines. The NRPE add-on consists of two pieces: the check_NRPE plugin, which resides on the local monitoring machine, the NRPE daemon, which runs on the remote Linux/Unix machine. When Nagios needs to monitor a resource of service from a remote Linux/Unix machine, Nagios will execute the check_NRPE plugin and tell it what service needs to be checked. The check_NRPE plugin contacts the NRPE daemon on the remote host over an optionally SSL protected connection. The NRPE daemon runs the appropriate Nagios plugin to check the service or resource. The results from the service check are passed from the NRPE daemon back to the check_NRPE plugin, which then returns the check results to the Nagios process. Question 27. Explain distributed monitoring. Answer. Nagios can be configured to support distributed monitoring of network services and resources. When setting up a distributed monitoring environment with Nagios, there are differences in the way the central and distributed servers are configured. The function of a distributed server is to actively perform checks all the services you define for a cluster of hosts. It basically just means an arbitrary group of hosts on your network. Depending on your network layout, you may have several clusters at one physical location, or each cluster may be separated by a WAN, its own firewall, etc. There is one distributed server that runs Nagios and monitors the services on the hosts in each cluster. A distributed server is usually a bare bones installation of Nagios. It doesn't have to have the web interface installed, send out notifications, run event handler scripts, or do anything other than execute service checks if you don't want it to. The purpose of the central server is to simply listen for service check results from one or more distributed servers. Even though services are occasionally actively checked from the central server, the active checks are only performed in dire circumstances. Question 28. Explain how flap detection works in Nagios. Answer. Nagios supports optional detection of hosts and services that are flapping. Flapping occurs when a service or host changes state too frequently, resulting in a storm of problem and recovery notifications. Flapping can be indicative of configuration problems, i.e. thresholds set too low, troublesome services, or real network problems. Whenever Nagios checks the status of a host or service, it will check to see if it has started or stopped flapping. It does this by storing the results of the last 21 checks of the host or service, analyzing the historical check results and determine where state changes/transitions occur, using the state transitions to determine a percent state change value, a measure of change for the host or service, comparing the percent state change value against low and high flapping thresholds. A host or service is determined to have started flapping when its percent state change first exceeds a high flapping threshold. A host or service is determined to have stopped flapping when its percent state goes below a low flapping threshold, assuming that it was previously flapping. The historical service check results are examined to determine where state changes/transitions occur. State changes occur when an archived state is different from the archived state that immediately precedes it chronologically. Since we keep the results of the last 21 service checks in the array, there is a possibility of having at most 20 state changes. The flap detection logic uses the state changes to determine an overall percent state change for the service. This is a measure of volatility/change for the service. Services that never change state will have a 0% state change value, while services that change state each time they're checked will have 100% state change. Most services will have a percent state change somewhere in between. Question 29. What is state stalking? Answer. Stalking is purely for logging purposes. When stalking is enabled for a particular host or service, Nagios will watch that host or service very carefully and log any changes it sees in the output of check results. As you'll see, it can be very helpful to you in later analysis of the log files. Under normal circumstances, the result of a host or service check is only logged if the host or service has changed state since it was last checked. There are a few exceptions to this, but for the most part, that's the rule. If you enable stalking for one or more states of a particular host or service, Nagios will log the results of the host or service check if the output from the check differs from the output from the previous check. Question 30. What is the difference between Nagios XI and Nagios Core? Answer. Nagios XI is a paid version and Nagios Core is a free version. Nagios XI includes lot of features which we can modify using web interface. Nagios Core default not includes all the features we have to implement by installing plugins.